Hi everyone, we are going to continue talking about error. Okay, now what we're going to do is specifically talk about what to do with an alternating series. Okay, so as you know, if the terms are decreasing in magnitude, the signs alternate, and you take the limit to infinity and you get 0, then it is convergent. Okay, now what's important to note is that this decreasing in magnitude thing, it could happen eventually. Okay, it doesn't have to happen right away. For some alternating series, it kind of meanders, it kind of like, and then all of a sudden it starts decreasing. So long as the terms do eventually decrease, it still fits this. Okay, it's still okay. So that's just something to watch out for. All right, so let's go through an example. Hey, we have a Taylor series about 2, and it's convergent in my interval, obviously. The nth derivative is given here, and they want me to write a second degree Taylor polynomial. Right, so I'm writing p sub 2, so my constant. So I need to, I need to know what f of 2 is, and then f prime of 2, and then f double prime of 2. All right, so this is my basic formula for a second degree Taylor polynomial. So let's just plug in what we know. Right, well, they told me that f of 2 is 1/3. And now I have to figure out what f prime of 2 is. So I'm going to plug 2 in, and so f prime of 2, sorry, I'm going to plug 1 in. So f prime of 2, I'm plugging 1 in, is going to be negative 1 over 3 to the first power, or negative 1/3. Right, so plus negative 1/3 x minus 2. Right, now I have to figure out what f double prime of 2 is. So I'm going to plug 2 in for n. And it's going to be negative 1 squared, which is 1, over 3 squared, which is 9. So 1/9 over 2 factorial x minus 2 squared. All right, so here's my second degree Taylor polynomial. Now they want me to show that an approximation of 3 gives me an error of less than 1/100th. All right, well, here's what I know. I know that my error is going to be less than my next term. So I found up to the second derivative, so I need to find up to the third derivative. Okay, so third derivative of 3. Okay, so I'm plugging 3 in right here. Remember, this would normally be x, but I'm plugging 3 in because that's what we're trying to approximate. Okay, these 2's are because that is where I'm centered. This 3 is because that's what I'm approximating. This 3, and this 3 come because it's the third degree term of my Taylor polynomial. Okay, so I do some simplification. I get negative 1 over 27 over 3 factorial, which is 1 over 162, which is definitely less than 1/100th. Okay, so this error is in fact less than 1/100th. Okay, let's do another one. This time we're given a graph. Okay, so we're going to look at this in a second. First, they want us to find the third degree Taylor polynomial about x equals 2. So I got to write out some stuff. Thankfully, this time they gave us all of our information. So I start with 4 as my constant, minus 1/3 x minus 2, minus 1/5 over 2 factorial times x minus 2 to the second power, and then plus 3/7 over 3 factorial x minus 2 to the third power. All right, now they want me to use this to estimate f of 2.8. So I'm going to plug 2.8 in here. Well, f of 2.8 is going to be approximately p sub 3 of 2.8. Right, so I'm going to plug 2.8 in, and 2.8 minus 2 is 0.8. So I end up with 0.8 in for all of these. Right, and you plug that into your calculator, you get 3.7059. Okay, now they want me to use this graph to show that my error is less than 1/8. Okay, so here's what I'm paying attention about my graph. Between 2 and 3, okay, my values goes from 3 to 7. Okay, so here's what's important. I'm centered at 2. This is my center. Okay, I'm estimating 2.8, which is about here maybe. I don't really know. Doesn't really matter. Okay, we'll say that's about 2.8. Okay, well the biggest that 2.8 could be is 7. Okay, I know that it's bounded by 7. I know it's not 7, but I also know that 7 is greater than whatever value exists at 2.8. So I'm going to go ahead and use 7 as my maximum value. All right, that's what's important here. I'm going to use 7 as my maximum value. That's all the information that I have from this graph. Okay, so I'm going to use it. I'm not going to estimate some number for 2.8. They don't find the slope or anything like that. Okay, I don't know any other information about this graph. All I know is that the value at 3 is 7. 2.8 is very close to 3. And the y value for 2.8 is under that of the y value at 3. So I know that the y value of 2.8 is going to be less than 7. I can use 7 as my max. Okay, so I know that my error, I'm going to write that a lot better. Okay, I know that my error has to be less than or equal to my maximum value. I'm going to say as 7 over 4 factorial, and then 2.8 minus 2 to the 4th power. All right, so again, let's break down where these numbers came from. 2.8 is what I'm estimating. 2 is my center. This 4 and this 4 factorial are because I am evaluating to the 4th derivative. 7 is the maximum value of my 4th derivative graph between 2 and 2.8. All right, if you evaluate this, you get 0.119, which is less than 1/8. Okay, 1/8 is 0.125, and 0.119 is indeed less than that, so we're good. Okay, that's it. See y'all later.